Hi guys, Cook and Hines here. We created a separate video for the back of Station 5 because it was a little more sophisticated. So Ms. Hines, you want to get us started on the directions?
I'd love to, Miss Cook.
Awesome.
So our directions say Wayne and Ambria are expecting their first child. They have a family history of cystic fibrosis and want to know their chances of passing the disease to their kids. Use the information below to shade the pedigree to show the inheritance of cystic fibrosis in their family. Miss Cook, why are we bothering to do this? What's the point of pedigrees?
Well, pedigrees are really interesting because it allows you to look at multiple individuals over multiple generations to see whether or not something is moving from one generation to the next. Also, if you understand kind of the tricks of the pedigree, you can figure out whether something is dominant or recessive. But something that you can also do, because Ms. Hines went ahead and she hammered out the question as she was reading the directions, we've already talked about cystic fibrosis. So if you already have some background knowledge about cystic fibrosis, that will do wonders for you as you're trying to figure out how to negotiate the pedigree further down on the worksheet. So what have we talked about in terms of cystic fibrosis? Have we discussed any characteristics in class?
I think I remember we talked about how cystic fibrosis is a recessive disease.
Oh, that's right.
I remember learning about that, which means it's a weaker gene and that you have to get 2 copies of the allele for this gene in order to actually have cystic fibrosis.
And if something's recessive, are we using a capital letter or are we using a lowercase letter?
We're going to use a lowercase letter to represent cystic fibrosis. Now, I want to stay away from C's because big and little C's sound the same. So let's use
hate C's.
Little f will be cystic fibrosis. I'm going to abbreviate it CF. And we'll make big F normal, or not cystic fibrosis.
Awesome. Now, what Ms. Hines is doing for us, she's creating our key that we've talked about multiple times over the last couple of weeks. This key basically serves as your brain on paper so that you don't get confused, because word problems, they're designed to confuse you intentionally. So if you have all of this information written down on your paper already, it makes the rest of the word problem really easy to tackle.
Should we get started?
Yeah, let's do it.
Okay, so here's our pedigree, our family tree. I see at the bottom here that I have Wayne and Ambria, my 2 individuals that have come in for genetic counseling and want to know about their family history of cystic fibrosis. So we're going to go ahead and take a look at Wayne's family history. Ms. Cook, do you want to fly us over to Wayne's family history?
Sure, but before we do, I just want to bring something up. Ms. Hines and Ms. Hanson and myself, we're trying to make this as easy as possible for you guys. So if you look at the top, we've already given you a key. So do you want to review the parts of the key really quickly?
Yeah, let's take a look at our key. So we've got 2 symbols for female. The symbol for female is circle, and if it's not shaded in, if it's an empty circle, that means that the female is unaffected. They do not have cystic fibrosis. If it is shaded in, that means that the female does have cystic fibrosis. They are affected. Let's go ahead and write CF right there so we remember what it means to be affected in this pedigree. Now we've got 2 symbols for males. They're both squares, but again, unaffected males, the males that are normal, are not shaded in. Affected males, the males with cystic fibrosis, they're going to be shaded in. So our goal is to figure out who in this family is affected so that we can shade them in and make sure our pedigree matches this key.
All right, awesome. So now let's go ahead and look at the actual directions that have been given to us for our family history. So in the family history, it says Wayne has CF. So he actually has this particular disorder. Then it says Wayne has 1 brother and 2 sisters. So let's just stop here, because if we take on too much information, we're going to get confused. So let's start with the fact that Wayne has CF. Let's go ahead and look on our chart and see whether or not Wayne is located, or where Wayne is located, and we can go ahead and fill him in. So on our chart, we have Wayne. So if we have Wayne, we know that he has it, and if he's affected, we need to go ahead and fill him in. Then it says Wayne has 1 brother and 2 sisters. And we can see that because we see 2 circles and 1 square. And again, if you forget what the circles and the squares are, you can go back and look up at your key. That's what I always do. It's hard to keep everything straight.
Yeah.
All right, now we need to look at Wayne's brother. It says Wayne's brother has CF, but his sisters do not. So which shapes are the brothers again, Ms. Hines?
So the brothers are male, so they're going to be square. So right here we've got Wayne's brother.
And in our directions, it says that Wayne's brother actually has CF, unfortunately.
Right, so we're going to have to shade in his brother because he is affected.
Okay. And then the other two shapes represent?
His sisters, because they're circles and they're female.
Okay. And then in the directions it says that his sisters, fortunately, do not have this particular genetic condition.
Right, so we're going to leave them unshaded.
Okay.
Because they are not affected.
Then the next thing tells us to pay attention to the previous generation. So we're looking to Wayne's parents. So how do we know that those are Wayne's parents, Ms. Hines?
Because there is a vertical line that connects Wayne and his brothers and sisters to this circle and square. This vertical line is a separation between the generations. And then this circle and square are attached by a horizontal line that goes right into the middle of them, which means that these two are a mating or a cross. So they're Wayne's parents.
Okay, so let's see what it says. It says neither Wayne's parents had the disease.
So what I'm thinking to myself is that means that they are not affected. They don't have CF, so we don't need to worry about shading them in.
Awesome. That's kind of interesting how we're not filling anything in there, but if you look down to the next generation, we have two siblings that have the disease, and then their other two siblings don't.
Right, so I'm already thinking that this might be a trait that is skipping generations because the parents don't have it, but the kids do, which fits with what we already knew about cystic fibrosis from class.
Awesome. All right, now we're going to jump up and look at the generation that precedes his parents. So we're going up to the very first generation. Yeah. So how do we, if we looked at this, Ms. Hines, vertically, could we easily count how many generations we have?
We could. We could start up here and we could label this generation 1. And usually we use Roman numerals for the generations. And then we see this vertical line going down. So now we're at generation 2. And then we have another vertical line going down. So this is generation 3. So again, the first generation would be the grandparents. The second generation would be the parents. And then the third generation would be the kids.
Awesome. So it's an easy way to show lots of people in a family in a very small space.
Yeah.
All right, so let's look. It says Wayne's maternal grandfather, so his mom's dad. So I guess we need to find dad.
So here's his mom, and here's his dad. I know that because his mom is a circle, she's female, and his dad is a square, is male.
Okay.
And so I'm looking for his mom's dad, which is going to be up here. So this is going to be Wayne's maternal. I'm going to just put an M for maternal grandfather.
Awesome. And it says, according to our directions, that Wayne's maternal grandfather actually has the disease.
So we got to shade him in. He's affected. So let me go ahead and shade in Wayne's maternal grandfather.
Okay. And then the last thing that it says about Wayne is that neither of Wayne's paternal grandparents, so paternal, we're talking about his dad.
Right.
All right, so his dad's parents.
Here's his dad's parents, his dad's mom, and his dad's dad.
And it says that neither of them have the disease.
So we're going to leave them unshaded.
Okay, so it looks like we have Wayne's side of the family completely taken care of.
Right, we got to move on to Ambria.
All right, so let's look at Ambria. It says on our directions that Ambria does not have CF.
Okay, so we're going to leave Ambria unshaded. She's not affected by this disease.
Okay, but Ambria has two sisters, and one of them has CF. So what are we going to do if we have two? Can we just pick and choose?
In this case, we can, because it didn't specify which sister it is. We're just going to go ahead and pick one of these sisters and shade them in.
Okay. So only one out of the three children, in this case all the children were girls, actually has the particular disease.
Right.
Okay, so what else does it say? It says neither of Ambria's parents had the disease.
So again, I'm going to go up a previous generation to the second generation to look at Ambria's parents. Here's Ambria's mom, the circle, the female, and here's Ambria's dad. And because neither of them had the disease, I'm not going to shade either one in. I'm going to leave them empty.
And I notice again, Ms. Hines, that if we compare Ambria to her parents or compare Wayne to his parents, the same thing has happened. It looks like they kind of got the disease out of nowhere because it skipped a generation.
Right. So again, that's kind of fitting with what I know about cystic fibrosis, that it's a recessive disease. Remember, these recessive diseases can hide out because they're weaker genes and they don't always show up.
Awesome. All right. Then it says Ambria's maternal grandmother, so her mom's mom.
Okay, so I'm looking at her mom, and then I'm going up a generation to her mom's mom. So that's going to be her maternal grandmother.
And unfortunately, according to the information that we have, her maternal grandmother actually had this disease.
All right, so we're going to have to shade in her maternal grandmother.
Okay. And then the last thing that our directions tell us is that Ambria's paternal grandfather.
Okay, so her dad's dad, so I'm going up a generation from her dad to her paternal grandfather.
It says that he also had the disease.
So I'm going to go ahead and shade him in too.
All right, so does that take care of our entire pedigree?
I think so. I think we've got our whole pedigree complete. So now we just need to go down to the bottom in order to look at the question that we need to answer for Ambria and Wayne about their family history.
And Ms. Hines, is it okay if we leave this up on the screen so that they can see it while we discuss the question?
Yeah, that sounds good.
All right, so let me read it to you, and then we can figure out what the answer should be. It
Okay.
says, based on the pedigree that we've created, do you think that cystic fibrosis is dominant or recessive? That's the first part of the question. So is it dominant or is it recessive?
So what's great about this is I have some background knowledge from class about this disease. So I know from class that this is a recessive disease, and now I can just use my pedigree to confirm what I already know. So I'm looking at this pedigree, and again, I'm thinking to myself, not many people have this disease, and it seems to skip generations. It's in the grandparents in that first generation. It's not in any of the parents, and then it's in the third. Does that fit with a recessive disease?
I think so. I think the defining characteristic for a recessive trait, whether it's a disease or just happens to be some phenotype like hitchhiker's thumb, we know that it appears and then disappears. It's really weird. It almost seems like it comes out of, it appears in a generation out of nowhere. But if you look back far enough in the pedigree, you can see that it's not really out of nowhere. It just skips generations.
Right, so I'm going to write something about that on my paper, about how this disease seems to skip generations.
And so if I did that on my paper, if I wrote that it skipped generations, and that's why I believe it's a recessive phenotype, I've already answered the second part of the question, which is why.
Right, so we are finished with the back of our pedigree station problem.
Awesome. Thanks, guys.